Hello, so this is question number 33 from 2022 IIT JAM Maths paper. So here it is given that if in a closed interval 0 to 1 to 0 comma 1, okay, so this is defined, the function fx is defined over here. Fx is equal to 1 for x is equal to 0, 1 by n for x equal to for rational 1 and 0 for when x is the interval is irrational, and g is defined. So in this interval 0 comma 1 to 0 comma 1, and gx is 0 when x equal to 0 and 1 for the semi closed interval 0 comma 1. So we have to find which of the following is or are true. So we have to find whether this fx gx f composite x and g composite f, these are integrable functional. Okay, so let's start with the gx. So what it is given that from the function given that 0 and 1 x equal to 0, and this belongs to the interval of 0 comma 1. So from here you can get that gx is a bounded sequence. It is bounded and it is only discontinuous. So at x equal to 0 gx is discontinuous, right? Only the from here discontinuous, right? So from here we can get that it has number of discontinuity is finite. So these two conditions is there. Gx is bounded and it is discontinuable at this discontinuity is finite. So from here you can say that gx is Riemann integral. Okay, so gx is Riemann integrable. So in the interval we have already defined this closed interval 0 comma 1. Now let's check with fx. Okay, so first of all we know that in Riemann integral, so the finer the partition, the more it is approximate the equation will be, that it will be Riemann integrable. So we can consider the partition over here from 0 to x in the interval. So we can write this x to 1 to interval in this. So it can be written as, so we can write 0 comma 1, 0 is equal to x0, which is less than x1, less than x2, less than x of n minus 1, less than xn equal to 1, right? So this is the 0 comma 1 closed interval we have defined. Now let's check with the fn function, the fx of, let me check whether fx is a Riemann integrable or not. So if we consider the upper sum of f corresponding to the partition P, so we can write that u of pf as I equal to 1 comma n m of I del of x. Okay. So now here mi is the supremum. Okay, so this is the supremum of fx in this interval del of xi. So what is the del of xi? So you can write del of xi as, in the interval x of I minus 1, x of I. So this is the supremum value of fx in this particular interval, del of xi. So if I, so now if I write this in this way, so m1 is x1 minus x0, x2 minus x1, and after that mn, x of n minus, it will be x of n of n minus of x of n minus 1. Okay, so we can write it in this way, and we have already considered this. Now check with this, that 0 is equal to this x0 and xn is equal to 1, and every this we are doing the partition, so you can say this is the partition in this manner. Okay, so from here we can state that this x0, it is 0, right, and xn it will be 1, right. So we can rewrite this equation as m of 1, and what will be the m1? We have to find the supremum value of n1. So here we can just check with the condition that fx is equal to this. Look at the condition over here. So the fx is 1 is x equal to 0. So x is not equal to 0 over here in the first m1, the supremum, first in supremum, that will get x minus 1 minus x0. So it will not be 1, and this is also this, it is not an irrational. So out of these two, one of two is this, whether it is a irrational number or irrational number. So x is in this form 1 by n1. So if we consider the supremum here as is not an irrational and take it as a rational number, so we can write this. So m1 will be 1 by n1. Okay, is x0 is 0, so we can write 1 by n1 plus 1 by n1 x1 plus 1 by n2 x2 minus x1, and we can go in this way, 1 by n subset n, 1 minus xn minus 1, right. So this is the upper sum. Now we calculate the lower sum of f corresponding to the partition P, and we can write it as in this way, this integration of I to n m of I del of xi. Okay, and this mi is the infimum of this f function fx in this interval that I mentioned before also, x of I minus 1 comma xi. So we can similarly we can write this summation as it will be m0 x1 minus x0 plus, I'll just take it as from m1, m2 x2 minus x1 up to, so here we will consider as m of n into xn minus xn minus 1, right. So this we can do. So this is the infimum of fx. So if we write in the similar manner and we just take this as 1 by n1 dash x1 by 1 by n2 dash, so this is n2 dash x2 minus x1 plus, and we can write it in this way, 1 by n dash 1 minus xn minus 1. You can write it in this way, right? Now if we just do the difference between this upper sum and the lower sum, so we have this Q of PF minus L of PF, and if we took the difference between them, so it will be 1 by n1 by 1 by n1 dash is of x1 plus 1 by n2 by 1 by n2 dash, so it will be x2 minus x1, and we can do it up to 1 by nn dash, it will be 1 minus x of n minus 1. Right, now if we keep take the mod of this, so that all the value will remain positive. If you give a mod of this value, so if you take this, all everything within mod, so what will happen? So now this 1 by n1, okay, so this value will be 1 by n1 minus 1 by n1, so this n1 dash, so this every value, it will be very less, so it will be less than this epsilon and n. We are subtracting this itself a small value. If we subtract it from, so it will be a much more smaller value. Similarly, all of the remaining terms, if you find, so it is also epsilon by n less than, so here it is also epsilon by n. So from here you can get that this, it is the mod of, so it is n of epsilon by n, right? It is less than. So when you this U of PF minus L of PF, it is less than epsilon, so we can conclude, we know from the definition of Riemann integral, so this fx will be Riemann integral, right? So we have both fx and gx from this option is both are Riemann integrable in this f and g on 0 and 1. So we have to find the composite function of f0, f composite g and g composite f, whether it is Riemann integrable in 0 and 1. So we have to check with the composite function of f fog, that is the f composite g. So this is also 0, 1 integrable. Okay. Now we will check with the composite function, whether that is integrable or not. So this is f of gx, the fog function, you can say like this way. So it is f of gx So f of gx is, now see the condition that in the is given already, is f of gx in the question you can find. So g is 0 when x equal to 0, okay, and 1 when x is belong to this interval 0 comma semi-closed interval. So how we will write this? So it will be f of 0 for x equal to 0 and f of 1 when x belong to this closed interval semi-closed interval 0, and f of 0 is 1, right? So f of 0 is 1 for x equal to 0, and f of 1 is also 1 for x belong to this semi-closed interval, right? So this composite function f composite g of x, it is 1 for all x belong to the interval, yeah, so it is all x this belong to this interval 0 comma 1. So it is also Riemann integrable, correct, this f composite g function, because why? This is a constant, this is a constant function. Got this. So this constant function means, so there is a constant function, which means it is bounded as well as continuous. So f of g is also fog x, this f composite g is a Riemann integral. Now let's check with the Goff function, that is our GOF, this g composite f. How can we write that? So GOF of x is g of fx, and from the question we can, so we can write it in this way, that so g of 1 fx is equal to 1 as x equal to 0. So g will be 1 by n when fx is rational, m by n, and g of 0 when x is this belongs to this irrational, right? So this is the GOF for this particular fx value we put over here, the condition we have set. Now what will be the value for the g? So it is 1 at x equal to 0, g of 1 is 1, g of 1 by n is 1 for x equal to any rational number, okay, is x equal to m by n, and it is 0 for x belong to this set of irrational number or q of complementary, right? So here we can simplify it in this way, that this can be written as, so this is 1 when x belongs to the set of q, and it is 0 when it is belongs to the set of q complementary, right? You can write it in this manner. So from here, so x, so this is also can write this x belong to this set of 0 comma 1. So now let's check with the u of UPF, sorry, u of GOF. Okay, so it is summation of I to n mi del of xi. We can write it in this manner, this m, so m1 del of x1 plus m2 del x2 up to, we can go up to mn del of xn, right? Now this m1 is the supremum value. We know this is the supremum of, so what is the supremum value? It is 1 over here, the upper bound, right? So for every m1, this m2, mn, okay, so this one is also supremum. So we can write it in this manner, this 1 comma 1 multiplied by del x1 del x2 1 del xn. So we can write del of x1 as x1 minus x0 plus of x2 minus x1 up to this will be plus of xn minus x of n minus 1. So we will see that every terms will get cancelled out, this every term, and we will left with xn minus x of 0. So what is xn? We have considered the partition that xn is 1 and x0 is 0, so it will be 1. So our value for the upper sum is 1. Now check with the LPF, this L of P of GOF, G composite F. So how I will write that? So it will be the summation of I equal to 1 to n m of I del of xi. So we can write it as m1 del x1 plus m2 del x2 up to, we can write it as mn del of xn. Del of xn, right? Now what is the infimum value of this m1, m2 and m3, mn? So infimum, it will be 0, right? So from here we can write the 0 plus 0 up to 0, so it will be the lower sum, it will be 0. Okay, so if we take this, that the difference between these two, u of p GOF minus L of p GOF is equal to 1, which is greater than epsilon. Okay, and we can conclude from here that this is the G composite F is not Riemann integrable, right? So in our case, only these three functions, that is f of x, g of x, and f composite g, these are Ryman. So we will check out the options, and it is interval is 0, 1. Okay. So from here we can just infer the option, which option is going to be correct. So this is A. We are in this case the A is correct option. B is also correct, and the composite F, composite G is correct. C. Okay. A, B, C for question number 33. These three options are correct.